Modulo n. Two integers and b are said to be congruent modulo n, where n is a natural number if a minus b over n is an integer. In this case, we write a is congruent to b modulo n. The number n is called the modulus. The statement a is congruent to b modulo n is called a congruence. So, for example, determine whether the congruence is true. 29 is congruent to 8 modulo 3. So 29 here is our A, and then B is 8, and N is equal to 3. So we need to know if the quotient of a difference of A and B over N is an integer. So we have A is 29 minus B, which is 8, and then we're going to divide this by 3. So 29 minus 8 is 21 divided by 3, and then we have 7, which is an integer. Therefore, we would say that the congruence 29 congruent to 8 modulo 3 is a true congruence. Now for number 2, we have 15 is congruent to 4 modulo 6. So our A is 15, B is 4, and N is 6. So we have now 15 minus 4 divided by 6. So that would be 11 divided by 6, which is not an integer. So you don't have to carry out the division because we know that it is not an integer. Therefore, since A 15 congruent to 4 modulo 6 is not a true congruence. So we have there false. Okay, so we have here another set of numbers. So determine whether the congruence is true. 7 is congruent to 12 modulo 5. Again, following the formula above, we have 7 minus 12 over 5. So we have negative 5 over 5, which is equal to negative 1, an integer. Therefore, the congruence here is true. For the second number, we have 15 minus 1 divided by 8. So 15 minus 1 is 14 divided by 8, which is not an integer because there would be a remainder when we divide 14 by 8. So therefore, we conclude that this congruence is false. We have an alternative method to find whether a congruence is true or not. So for our example, where 29 is congruent to 8 modulo 3, okay, so when we divide 29 by 3, we have a remainder of 2. And then if we divide 8 by 3, there is also a remainder of 2. So here, this is the alternate method. If A congruent B modulo n and A and B are whole numbers, then A and B have the same remainder when divided by n. Okay, so we have here our first application. Using the alternate method, determine whether the following are true congruence or not. So we have 33 is congruent to 49 modulo 4. If we divide 33 by the modulus of 4, then we have this is now 8 divided 8 remainder 1. Okay, whereas if we divide 49 by 4, we have here 12 remainder of 1 also. Since the remainder of 2 are the same, then we say that the congruence is true. Now for next number, 20 is congruent to 2 modulo 3. We divide 20 by 3. So we get here, that would be 6 remainder 2. And then if we divide 2 by 3, this would be equal to 0 with a remainder of 2. Now since the remainder of both are the same, then we say that the congruence is true. Okay?